And in your class, did you guys started the neural networks or
Yes,
what
sir.
should I say multi-perceptual layer?
Yes, sir, we started neural network.
All right, so we are seeing one neural network in the screen. Can you see the screen?
Yes, sir.
Okay. So in the screen, we are seeing a neural network. Basically, this neural network represent the AND function. All right. So all right. So suppose there is two input neuron x1 and x2, and they are connected with another neuron. All right. Y. So what is the connection or what will be the output? It will depend on what. What should we introduce before uh, sending those information from x1 to y? So what are the parameters we need to consider when we will be dealing with neurons? Can you tell me?
Weights and bias.
Very good. We need to consider these kind of parameters, right? So suppose I considered one as a weight for this connection x1 to y, and from x2 to y we are also considering one as a weight. All right. Okay. So we want to get a function or output like an AND gate, right? So what is the AND gate? AND gate basically indicates one and one. Both if the both inputs are one, in that case y would be one. In another cases 1 0 0 1 0 0, all the outputs will be given you the zero. Alright. So this is your output neuron, right? So it will ignite or it will activate if it meets the requirement, right? So requirement means I'm telling the threshold. It's supposed to have some threshold. So for this function, for this neuron, we consider the threshold as 2. So what will be the actually, so for this combination, can we check that x1 into 1 plus x2 into 1 equals to what? So if you put 1, x1 as a 1, x2 as a 1, you will get what? In total, you will get what? If you put 1 and 1, Papu.
Sir, two.
So 2 হচ্ছে আমাদের threshold, so 2 is matching with our threshold, right? In that case, it will fire the signal. Alright. Fire the signal means yes or true or something like that. It will fire. I mean yes or one. But if you put other combinations like 1 0 0 1 0 0, so if you put this combination 1 0, you'll get what? Here x1 is 1, x2 is 0. So you'll get 1. So this value doesn't meet the requirement, right? Doesn't meet the threshold. So therefore, it will not ignite any output. So the output will be zero. That means like an AND function. If you put the rest of the combinations, the neuron will be working like that. Do you understand how the neurons are actually working here? We here we didn't introduce the bias, but obviously we introduce the weight of the connections as well as we give the threshold for the neurons, the output neurons. Do you understand, everyone?
Yes, sir.
Okay. Now let me consider this function. We are now considered the OR gate, right? So what is the combination of OR? I mean, what is the output of the OR? So if we don't have one, in that case, our output will be one, right? So as you can see, the first combination, second combination, third combination, all the combination will give into you the positive signal, or the function will give you something, the positive thing. Uh, if you choose this combination 0 0, you're supposed to get 0. All right. So as you can see, for this OR gate, we consider this connection as a weight 2, and this connection also labeled as weight 2. So in this case, what would be the equation? X1 into 2 plus x2 into 2 equals to what? So what will depend on the combination? Which combination are you choosing? If you choose this combination, x1 into 1, x2 into equals to 1. So what you will get? If you choose the first combination, what are you
One.
gonna? You are gonna get what? I mean, I'm telling you from here. I'm checking the summation, summation of those inputs. You will get 4, right? Which actually greater than the threshold value. Threshold value was 2. So it is greater than 2. So therefore your neuron will ignite or fire a signal. That's why I'm telling 1. বুঝতে পারতেছি? বুঝতে পারিনি?
তো একটু যদি আবার রিপিট করতেন স্যার।
আচ্ছা। কোথায় ছিলাম? এটাতে। So I'm telling that this connection is weight of this connection is 2. Weight of this connection is 2, right? So you have to sum the inputs in the neuron. I mean, the neuron have three parts. I'll show this thing a bit later. At first, you sum whatever you're getting the inputs. Then you apply activation function. Then the output, whether it will ignite or not, whether it will give you 1 or 0. It has three, I mean, three steps. So first step is to sum all the information, right? So if you sum the information, the equation should be what? X1 into weight, which is 2, x2 into weight, which is 2, is equals to what? Is equals to what? It will depend on the combination. Suppose you choose this combination, 1 0. So what you are gonna get if you choose 1 0 combination?
2.
2. So does it match with your threshold? So if the function have to ignite, you have to match. I mean, it's something like that. That summation of xi, yi supposed to be equal or greater than threshold. So it is checking in this function. If it meets, then your output will ignite, or that means what I'm trying to say is that it will fire a signal as a 1. If it doesn't match with the requirement, it will fire 0. I mean nothing. Do you understand now?
স্যার
বলো।
sir, can you please record the session? My internet is not stable, so I'm not, you know, বাট মাঝে মাঝে ব্রেক করতেছে আর কি।
আমার তো রেকর্ড করার মতো কোনো রিসোর্সেস নাই।
ও
আমাদের তো মিটলিঙ্কও রেকর্ড করতে দেয় না।
আচ্ছা স্যার, তাহলে
জুমে করতে পারলে ভালো হইতো, জুমে মনে হয় রেকর্ড করতে পারা যায়, বাট আমি তো শুরু করে ফেলছি।
আচ্ছা স্যার, ঠিক থ্যাংক ইউ।
আচ্ছা, সবাই কি বুঝলাম কিনা হোয়াট এভার উই আর ডিসকাসিং? জোহায়ের,
জি স্যার, বুঝতে পেরেছি।
আব্দুল্লাল, সাকিব।
Yes, sir.
So these are the neurons, right? This is the way neurons work. So this, I mean, straightforward and function or function. But again, you can solve everything using this input layer and output layer. You need sometimes what? Hidden layer, right? Do you remember? In multi-layer perceptrons are discussed about the hidden layers. Am I right?
Yes, sir.
So sometimes we also need hidden layers. In that case, we just have to, I mean, get some inputs. Suppose these are the combination of inputs. Inputs will propagate from the in the forward direction. So next one will give provide the values as input. But before that, there will be some weights. If you provide bias, that will be another thing. So each neuron, they will calculate whatever they are receiving from x1, x2, weights, bias. After that, they will calculate whether I mean, after calculating, they will decide whether I should fire or not, whether I should be active or not. All right. So based on this propagation, in your output layer, your neuron will again calculate after getting everything. Suppose Z1 is not firing. I mean Z1 is not giving you anything. In that case, Z2 will give you some input. So Y will calculate whatever he is receiving from Z1 and Z2. After receiving the information, I mean, that neuron will decide that whether it meets its requirements or not. If meets the requirement, that in that case, Y again will fire something, I mean, give you something, or it will not provide you anything. So it is something like that. So that's the, I mean, overview. That's what I'm trying to discuss. I mean, this actually happen in the neuron when there are multiple connection in the neuron. As you can see here, the age is the activation value of unit j. I mean, suppose in previous layers there are some units j1, j2, j3, j4. All right. I mean, suppose before this neuron there is a layer, and in that layer there are two, three neurons, j1, j2, j3. So those activation values will come, but when the activation values will come to this neuron, it will bring some weights, right? Every connection will have some weights, so the weight will be calculated. I mean, here, so all the inputs and weights will be summation in this first portion, input function. Then whatever you just sum together everything, it will be it will go through a activation function, or we can say the threshold requirement. I mean thresholds. Suppose you also studied the activation function like ReLU, sigmoid, 10H. Do you remember? And I mean in the class you were supposed to read this activation function. মানে এগুলো কি পড়ানো হয়েছে? মানে বোর্ডে পড়ানো হয়েছে? সাদমান ইসলাম আলী,
জি স্যার।
তোমাদের কি ক্লাসের মধ্যে activation function পড়ানো হয়েছে?
ইয়েস স্যার। ইয়েস স্যার, পড়ানো হয়েছে।
So activation function is something like that, right? So if you put some values, it will give you some. I mean, suppose you just sigmoid is something like that, 1 divided by 1 plus e to the power minus x. So after calculating everything in this first half, you will put that value in activation function. So activation function can be anything, step function, sine function, sigmoid function, but after putting that value, you will get some values, right? Whether it is a positive one or negative one, whether it is a one or zero, right? That calculation is done in the middle, activation function. After putting that value, you will get something, right? One or zero, one or minus one. So whatever the output is from the activation function, this is A1, AI, and the output will be propagate to the next layers of neurons. বুঝতে পারলাম কিনা সবাই, whatever is happening. At first, it will receive every inputs, sum together, and put in the activation function, which is in the middle. The activation function will give you some produce one values, which will indicate whether it will uh, activate or not. Then whether the output will be propagated to the rest of the neurons. So that's the simple way to discuss about neuron. Do you understand, everyone?
Yes,
Yes.
sir.
নাহিদ আহমেদ শিহাব,
Yes, sir.
কোনো কোশ্চেন আছে?
No, sir. কোনো question.
মোতাসিম সিয়ান,
জি স্যার।
বুঝতে পেরেছি?
হ্যাঁ স্যার, বুঝতে পেরেছি স্যার।
So there are some activation functions, but these are not all activation functions. We have ReLU, 10H. There are many other activation functions as well, right? Um, so this is an example of with weight. This is a sorry bias with bias. So your neuron supposed to get some input with some weight, but sometimes we also have some bias. So bias would be a constant one. So this is an example of bias to this neuron. So that's the theoretical background that we'll be talking about. But I want to go through another slide to give you a broad idea or total idea what actually happened in the multi-layer perceptron architecture. Then we'll do some codes, basic code actually. So as you can see, this is the multi-layer perceptron architecture. So what do we have in the multi-layer perceptron architecture? Tasnuva.
Yes, sir.
So can you tell me what is multi-layer perceptron architecture? Regarding Masuba Aaron's question, ReLU is an activation function. Yes, we use that activation functions in a neuron to calculate the inputs, whatever it receives, and based on the calculation, the output will produce. Okay, Tasnuva, what is multi-layer perceptron model?
উম, স্যার মানে কিছু হিডেন লেয়ার যে থাকে ইনপুট আউটপুট ছাড়া।
কয়টা হিডেন লেয়ার থাকবে?
জি
কয়টা হিডেন লেয়ার থাকবে?
উম, স্যার দুইটা না,
দুইটাই কেন থাকবে?
স্যার বলতে পারছি না।
আচ্ছা, who can answer me the question? I mean, what is the multi-layer perceptron model? Anyone?
স্যার দুইটা বা দুইটার বেশি থাকলে আমরা বলি মাল্টি লেয়ার।
আচ্ছা, normally আমাদের থাকে we have two layers of neurons. One is input and output, right? So that's the normal neural architecture. I mean, normal neurons. But when you have three or more layers, including input and output, it can have one layer of hidden layers. It can have two layers of hidden layers. I mean, more than some. I mean, in the middle, one layer or more than one layer. In total, they will produce a multi-layer perceptron model. Why we need this multi-layer perception model, anyone?
স্যার
Not
মাল্টিপল ইনপুট থাকলে ওটাকে ম্যানেজ করার জন্য।
Very good. Using the normal architecture, I mean, here, if we apply input output layer like we did uh, in the previous slide, so it will produce one straight line. Like why one straight line? Because each layer is considering x1, y1 with some weights and some bias. So it is an equation like a state function. I mean straight line. So each neuron will produce one, I mean, straight line. But sometimes we cannot solve, I mean, most of the times we cannot solve all our problems with straight line. And in that case, we need multiple layers. I mean, as you can see here, a hidden layer where we are, I mean, address those non-linear linearity to that hidden layer to address those problems. Like here, আচ্ছা আমি একে দেখাইতে পারবো? ওকে, এখানে হচ্ছে গিয়ে we can do that because if we draw this line x and y, right? So when it is 1 1, it is 1. When it is 1 0, it is 0. When it is 1 0 1 0, when it is 0 0 0. So how can we how can we actually solve this problem? Basically by drawing a line, right? So all the positives are on the right side, on the negative of the uh, false value on the left hand side. So this straight line actually work as an AND gate. Whatever is in the right side of that portion, that will give you 1. If you consider the AND function here, so if you consider this OR gate, it will be something like that: 1 1 1 0. You can also draw this line and solve this problem, right? The problems occur when I'm not sure about the output, but when you consider XOR gate. So what is XOR gate? Do you remember what is the combination of XOR gate? As far as I remember, that was 0 0 give you 0 and 1 1 give you 0. 1 0 combination will give you 1 and 0 1, and 1 0 combination will give you 1. Now, can you draw one line and solve this problem? Can we draw one straight line and solve that problem?
No, sir.
কেন? কারণ যদি এইভাবে ড্রটা if we draw a straight line like here, but still it has 0 on the left hand side, right? But again, if I do what? কিভাবে আঁকবো বলো? কিভাবে একে প্রবলেম সলভ করা যেতে পারে? I mean, there's no option actually with a one straight line. But what if I draw two straight lines and say whatever is the right hand side of this line is negative, whatever is the left hand side of this line is negative. In between, everything will be positive. So it solves the problem, right? Isn't it? If we have two lines, does it does it solve the problem?
Yes, sir.
So for that, actually, for that reason, we need two neurons in the middle, and which construct the hidden layer. Therefore, it draws two straight line and solve the problem. এই যে একজোর গেটের প্রবলেমটা এখানে দেখানো হয়েছিল, হোয়াট এভার ইট ইজ। তোমরা কি বুঝতে পারলা কিনা?
Sir, can you please repeat the part? মানে কেন দুইটা লেয়ার লাগে?
Can anyone explain him কেন দুটো লেয়ার লাগছিল এক্সোগেটে? কে বুঝছো? জুহার তাজওয়ার?
স্যার দুইটা লেয়ার মানে আমরা একবারে এক লাইন দিয়ে সলভ করতে পারি না, সেজন্য স্যার দুইটা লেয়ার ব্যবহার করতেছি।
Why we can solve that problem with one?
স্যার মানে ভ্যালুগুলো যেটা ছিল এখানে মানে
আচ্ছা, considering this problem, all right? তো এখানে কি হচ্ছে? We have +1, +1, -1, -1. এটাকে তো সলভ করা পসিবল, এটা না। I mean, exorbit actually. If we consider this 1, 1, 0, 0. Suppose this problem. So can you solve Bishojit with one straight line?
জি স্যার, ওয়ান ওয়ানের মানে ইন্টারসেকশন তো ওইটা সলভ করা পসিবল যদি ওয়ান আর ওয়ান দিয়ে ইন্টারসেক্ট করি আমরা একটা।
মানে with one straight line, can you solve this problem?
মানে স্যার এটা ওয়ান আর ওয়ান এর মধ্যে ইন্টারসেক্ট করে এরকম একটা লাইন যদি ড্র করি দেন তাহলে তো স্যার
Intersect বলতে you have to draw one line which will, I mean, divide this negative and positive. So if you draw one line here, sorry, so still it has negative on this side. If you draw in line here, still it has one negative on the right hand, left hand side. So one straight line is never solving this kind of problem. To solve this problem, we need two lines, two straight lines, right? After that, we can tell in between the values will be positive, outside of this line will be negative. So that's why we needed two straight lines to solve XOR gate. বুঝতে পারলাম কিনা সবাই?
থ্যাংক ইউ স্যার।
ওকে, তো যেখানে ছিলাম, so this is a, I mean, a sigmoid function that we are discussing actually. So yeah, here the Vj. Do you remember what is Vj? Whatever the input is coming, all right, multiplying with the weights, we'll have to sum all the inputs with their weights and take the summation, which is Vj. This Vj will be go to the activation function. Suppose you choose the sigmoid activation function, in that case 1 divided by 1 plus e to the power minus a Vj. So based on your Vj values, তোমরা কি বুঝতে পারতেছো Vj কোনটা ছিল? What was Vj? আমি এখানে লিখতে পারতেছি না, লিখতে দিচ্ছে না। Vj কি ছিল বলো তো? What is Vj here?
স্যার আমাদের ক্ষেত্রে কি ভিজিটা সিগময়েড ফাংশন?
না না, Vj তো sigmoid ফাংশন না। দাঁড়াও আমি দেখে একটু বোঝানোর ট্রাই করি। আচ্ছা, alright. So যেটা বলছিলাম, suppose this is your neuron, right? I told you that a neuron has three parts to be considered. At first, suppose ধরো you have two or three inputs. Suppose three inputs, alright? This y1. Y1 is what? Output from the previous neuron. বুঝতে পারলাম? Suppose this is y2, this is your y3. And this y is y1, y2, y3 is coming from previous neurons. Is it all right? Everyone?
Yes, sir.
And each connection has some weights. Suppose this is a weight from 1, 2, and this neuron is 1. Alright? This is a J layer and this is K layer, suppose. So K layer first neuron. So your W11, that will be W uh, 1, 2, W13. Suppose I just rename. So here the Vj is what? Vj is summation of those input values with their weights. So it is W WJI YI. So basically it will be written as Y1 W11 Y2 W12 Y3 W13. বুঝতে পারলাম? Do you understand everyone?
Yes, sir.
So what is the weights? I don't know. You can I mean choose the weights for the connection, which is not part of this discussion. But suppose you provided some weights and you are giving some input. So after giving those values, you will get something, right? Suppose after doing the multiplication and summation, you get some values like 10. So this thing is calculated here. This Vj is calculated in the first part of the neuron. Clear, everyone? বুঝতে
Yes, sir.
পারছি? Okay. The next part will consider the sigmoid, I mean the activation function. Suppose I choose sigmoid function. In that case, it will be sigmoid of Vj. Alright? In the second portion of this neuron. So as you can see the sigmoid function here. Sigmoid function is something like that. Sorry, I just draw properly. So as you can see the sigmoid function in the left hand side of my screen. So it is something like that. Uh, when your Vj value is 0, then you will get some 0.5, but apart from that, এরকম কিছু একটা. So your Vj is what? 10, right? Somewhat 10. So your activation will calculate a point around 1, right? Am I not right, everyone?
Yes, sir.
Now your output output from this neuron, right? From this neuron, suppose it is tends to 1, suppose ধরো 0.9. So this neuron, whatever input you are providing after calculating the Vj, after going through the activation function, this output of this neuron is produced as it, and it is কত? 0.9, suppose. So these values will go where? This value will do what next? Can you tell me? এই ভ্যালুটা কোথায় যাবে এখন?
এটা আউটপুট তো স্যার এটাই তো।
No, মানে I mean I মানে it's আমি তো বলি নাই নিউরনটা আউটপুট। It can be hidden layer, right? I mean it doesn't matter whether it is input or output. If I told you that this K layer is the output layer, okay, this is the output what the time pairs was telling. But suppose this is not output layer, this is another hidden layer, and output layer is after two more hidden layers. Actually, whatever the output it produce, it will propagate this output to the next layer neurons. Clear, everyone?
Yes, sir.
ইয়েস স্যার।
Yes, sir.
ইয়েস স্যার।
বুঝতে পারলাম? এই যে দেখো এখানে y1 y2 y3 এগুলো কি হচ্ছিল? প্রিভিয়াস কোনো একটা লেয়ার থেকে তো আউটপুট প্রডিউস হচ্ছিল, তাই না? তারপর ওয়েট দিয়ে হচ্ছে নেক্সট লেয়ারে যাচ্ছিল, তাই না? So whatever output it produce, it will propagate the output to the next layer of neurons. Isn't it understandable,
ইয়েস
everyone?
স্যার।
Okay. So I'm just giving you the মানে 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 brief view of the multi-layer perceptron model. Actually, what happened next? You are just propagating what? You are propagating the input to the next level hidden layer, the output of the hidden layer to the next level hidden layer, the output of the hidden layer to the next level, and in this way you go to the where the output layer, and you in the end you produce the output, right? So this is the way to produce output from a multi-layer perceptor model, isn't it, everyone?
Yes, sir.
But
Yes,
suppose,
sir.
your expectation was that, sir, my output supposed to be something like 5, but my prediction is what? Is 3. So is it your correct answer? Okay, you build the neural network, you propagate the input, output, and everything. You just initialize, declare the weight bias, and you calculate the neuron values, and it will propagate through the output layer, and output will produce something. Everything you have done, it's a prediction, right? But if the prediction doesn't match, if you build a architecture at the beginning, should it match with your expectation? It will never match because you just build the architecture. You just have to train that architecture based on your data, right? নাকি তোমার expectation অনুযায়ী architecture build করা আছে, নাকি এগুলো
না,
শিখে বসে আছে? কোন architecture কিছু শিখে বসে না. You have to teach the architecture based on your data, right? Now, how that neurons or layers will learn, এটা কি বলতে পারবো? কে এম মুক্তার হোসেন,
জি স্যার।
বলো কি হবে তখন?
কোশ্চেনটা আরেকবার একটু যদি
আরেকবার কি বলবো?
স্যার কোশ্চেনটা।
কোশ্চেনটা বলছিলাম যে সাপোজ ইউ বিল্ড আর্কিটেকচার,
জি স্যার।
you provide the inputs layer, the inputs is propagating through the layers, and at the end it produces some output. But if it doesn't match with your expectation, I mean, if the prediction is not right, in that case you will have to do what? What should we have done?
স্যার লেয়ারগুলো বাড়ায় দেওয়া।
So লেয়ার বাড়ালাম, স্টিল ম্যাচ করতেছে না, তো তুমি আবার লেয়ার বাড়াবা। চিরঞ্জিত দাস,
স্যার আমি অ্যাকচুয়ালি শিওর না স্যার, আমি ক্লাসের বেশি কিছু শুনতেছি না।
হ্যাঁ, কে শুনতেছো? মায়মুনা জামান ফারাসা?
স্যার এরকম কি হবে আমরা লেবেলস ডেটা সেট নিয়ে ওয়েটস গুলা আপডেট করি নাকি
Yeah,
ওগুলা
yeah. I mean, that's the correct answer actually. So basically, I built architecture. I provide the weights randomly, or suppose I uniformly choose some weight. And when I provide the inputs, my inputs went through those weights and produce some output through that hidden layer. The hidden layer propagate the output to the next layer. In this way, I will get some output. So output, if the output is not right, that means what? That means your architecture didn't learn properly, right? In that case, you'll have to do what? You'll have to update the parameters inside the architecture. So whatever Maimuna was telling, that you have to update the weight weights of the connection, next time next time when I will predict something, it is more accurate than previous one. That's why we tell that we will calculate the error signals through backward propagation. Suppose your output is doesn't match, or your output is a disaster one, you'll have to do what? Go to the, I mean, through the back propagation, go to the next layer and update the weights. Go to the next layer and update the weights. So these are the equations to do that, and I should not go through, I mean, those equations in deep. I mean, I should not go through the mathematical equation at this moment, especially in the lab. So I'm just want to show you that if your output doesn't match, or you will have some error at the beginning. That's for sure. In that case, you'll have to back propagate and update the weights, and in this way, you'll have to go to until the input layer comes. All right. So we have two propagation, forward propagation and another is backward propagation. Forward propagation is to compute the neuron outputs. The backward propagation is to compute the error and to update the weights. So that's all about multi-layer perceptron model. Do you understand everyone?
Yes, sir.
Do you have any question? We just discussed about the what is necessary for this class. All right. So I am giving you the lab 05. This lab 5, right? So I'm giving you the notebook for this class, and we'll go through that notebook. After completing the notebook, we'll be done with our class. So you can see in the classroom. I just give you the notebook for this class, and this is artificial neural networks, and here we will be looking into the forward propagation, not backward propagation. Only the forward propagation will be done here. Can you see my screen, everyone? The code.
Yes, sir.
Yes, sir.
So in the classroom, I also give you this notebook. You can open that notebook and go through with me. So whatever I just talk till now. তো মানে I mean নোটবুকের মধ্যে যা আছে সবকিছু in the meantime আমরা discuss করেছি through lectures. So we'll just put those values on those equations and see whatever is coming through that equation. All right. So I'm just going through these codes. I'm just will be I'll just give you the overview, not line by line description, rather than an overview, whatever we discussed till now. So let's start formally defining the structure of the network. Like we said before, right? In a multi-layer perceptron model, you'll have to what? Design the architecture. That how many hidden layers should be there, how many uh, nodes in each layers. You can decide those parameters. So okay, suppose at first you have one input, one hidden layer, and number of nodes in hidden layer is 2, and number of output layer. This is very simple, right? It will be something like that: one input, one hidden layer with 2 nodes, and one output node. So in total 1, 2, 3, 4 চারটা নোড হবে আর কি. So we just initialize a very simple multi-layer perceptron model. Here there I mean this is a function file, not a function file actually. There is a code to allocate the weights and bias of each neuron. All right. So you can go through the comment and see whatever the code is given to you. I'm just giving you the overview that at first we initialize the weights. All right. Determine the name of the layer. At first we go through the layer. Suppose you have one hidden layer here, right? So we'll be going through that hidden layer. I mean, starting from the input layer, you will have some words from input layer to hidden layer. You will have some words from hidden layer to output layer. So through this code will be, I mean, this is like a for loop, right? Consider that when we iterate the matrix, we did what? We at first propagate through row. Suppose we are one through one for loop, we propagate through the row 1, row 2, row 3, row 4. Through another for loop we do what? আমরা হচ্ছে each row এর মধ্যে হচ্ছে যতগুলা কলাম আছে সেই কলামের ভ্যালুগুলো আপডেট করি. Do you remember when we uh, in triple one হচ্ছে maybe you use the for loop, you use nested for loop to propagate through a matrix. Through one for loop, you propagate through the row, and through another for loop, you propagate each values of that row. I mean the columns of that row. So basically, for using the first for loop, we will propagate through the layers, and using the second for loop, we will initialize the weights and bias associated with each nodes in that layer. That's the simplest explanation of this code. বুঝতে পারলাম? আমার জ্যাম্বোটা কোথায়? তো বেসিক্যালি কি হচ্ছে? Suppose input output layer. So you have some weights and connections, right? So using the first for loop, we are propagating that okay, I'm in the input layer, or I'm in the hidden layer, or I'm in the output layer. If you are in the input layer, you do not have to put any weight or bias, right? You don't have to. But if in the first hidden layer, so using the second for loop, you are initializing the weights or bias required for these two nodes, node 1, node 2. If you come to the output layer again, you have to initialize the weights, right? So using this portion of code, we do that. If I just run this code, we here as you can see, we put some random values. All right. So we put some random values, and in the weight we uniformly distributed those random values. So I just run this code. You can see the layer 1, node 1, this array 0.54, bias is 0.28, node 2, that is your hidden layer node 2, weight is 0.42, bias is 0.84, output layer weight is এত এত মানে it has two weights. I mean এখানে তো দুইটা weight তাই না, weight 1, weight 2. So it has an array of weights and bias. It has one bias. All right. So this is the way using this code we can what যেটা বলতেছিলাম যে একটু আগে যে we have to provide some weights or bias for each neuron. So we just have done that in this code. Do you understand, everyone?
Yes, sir.
Yes, sir.
Next, whatever we have done there, we are doing it here using a function. That's the all. Okay. So we using the above code, we initialize the weights and bias of our pre-training network of any hidden layer of any nodes, but we are just putting those codes in a function. That's all we have done. All right. Now suppose I tell you that okay, take 5 inputs. It's supposed to have 3 hidden layers. Has 3 nodes in the first layer, 2 nodes in the second layer, and 3 nodes in the third layer, and a one output layer. So how does it looks like? How does it looks like? Sorry, এটা মোছার থেকে নতুন একটা খোলাই ভালো. Suppose 1, 2, 3, 4, 5. These are input layer. The hidden layer, first hidden layer has 3 neurons, 2 neurons, 3 neurons, 1 neuron. So everything will be like that. So these were কি এই ওয়েটার থেকে আমাদের কানেকশন গুলো হবে. So I'm just telling you that okay, at first, like we were discussing at the beginning, we will give some random weights, random bias. That's fine. But like Maimuna Farasha said that if it is not work for our problems, obviously it will not work at the first trial. We will have to do what? We'll have to back propagate and update the weight. So, but at first we need to give something, right? Otherwise, if we do not give anything, this network will not generate anything. বুঝতে পারলাম, guys?
Yes, sir.
So Using that function, whatever we initialized, we just call that function and say, okay, I need first input nodes, 3 layers, hidden layers. These are the nodes at each hidden layer. So build me the architecture. So they build the architecture with the random weights and bias. All right. So we are done with the architecture, building the architecture. Now we need to do what? At each neuron, we need to calculate the total weight, sum of the weight. Do you remember? ওই যে bj বের করতেছিলাম, do you remember? We calculate the b for each neuron. কে মুক্তার হোসেন,
জি স্যার।
bj কিভাবে বের করতেছিলাম?
স্যার ওয়েট আর প্রিভিয়াস লেয়ারের আউটপুট যেটা মানে মেইনলি ইনপুট যেটা ওইটার সাথে মাল্টিপ্লাই করে আর দেন সবগুলা সাম করে।
ভেরি গুড। বাস থাকলে সেগুলো আমরা অ্যাড করবো, তাই না?
জি স্যার।
আচ্ছা, so this code is doing that. Compute weighted sum, bj actually, whatever we discussed in terms of our slides. নাও এটা কি করতেছে? আচ্ছা, এটা হচ্ছে তোমাকে 5টা ইনপুট দিচ্ছে আর কি, মানে ওই ওই যে y1 y2 মানে I mean x1 x2 x3 x4 x5. So this code is randomly generating some inputs since you do not have any inputs. All right, so the inputs is something like that, so we are not bothered about that. But we need to do what? We need to get the output from the through the activation function. We need to do what? Get an output from the, do you remember bj calculate করলাম, তারপর হচ্ছে activation layer দিয়ে গেলাম, তারপর এখান থেকে একটা আউটপুট জেনারেট হবে, তাই না? That was our objective from a neuron. Do you remember?
Yes, sir.
So calculate তো করলাম, করার পর সেটা আমাকে একটা activation function দিয়ে যেতে হবে. So this is actually going to an activation function, and after that your output will produced. বুঝতে পারলাম? তুমি তো bj-টা কি করো, activation function ইকুয়েশনে বসাও যে 1 divided by 1 plus e to the power minus bj. এটা তো বসালাম, এই যে এখানে এটাতে বসালাম, বাট আমরা আউটপুটটা এখান থেকে পাচ্ছি। অলরাইট, ক্লিয়ার কিনা, সবাই বুঝতে পারছে কিনা? মাসুবায়রন,
Yes, sir.
do you understand whatever we discussed till now?
So I've missed a step on the initial part of the called the network, small network.
Okay.
Just the initial one.
Okay, so we are trying to build an architecture where there will be 5 inputs, 3 hidden layers.
Yes,
First
sir.
hidden layer will have 3 nodes. Second hidden layer will be 2 nodes. Third hidden layer will have 3 nodes. Output layer will have only 1 node. So this is the architecture we need, and I just draw that architecture here. Can you see that? Hidden
Yes,
layer
sir.
1, hidden layer 2, hidden layer 3, output layer, input layer. All right. Then we have done what? We are defining a function so that we can calculate all the inputs and bias, inputs and weights coming to a node. Do you remember we calculate the bj?
Yes.
This function is doing that. All right. Next, in this code, we are generating some random inputs x1, x2, x3, x4, x5. That is random. We are not bothered about that. Here we are doing what? We are actually calculating the summation. Actually, which are calculated here. All right. The
Yes.
sum of that one, whatever is coming, computed weighted sum. So আসার পর কি করতে হবে? We will have to, whatever we get the bj, we will have to put this bj into a what? Activation function. So this function is doing that if I put the weighted sum here, so it will build something like, okay, sigmoid bj. This function is doing simple as that, and here your output was produced, right? So this code is actually producing your output, And if you print the output, you will see the output actually, whatever is coming out from this neuron. Do you understand, Ataur Rahman?
Yes, sir.
Okay. So poop game. Can you hear me?
Yes, sir.
So what does it output means actually? So whatever output we get from here, what does it mean actually? And this output will go to where?
This output might go to another layer.
Suppose your output from here is something 0.79, right? And this
Yes,
neuron supposes this neuron. So this 7.9 will go to the second hidden layer,
second hidden layer.
and the input for those layer neuron would be 0.79. 0.79. But obviously the weight is different, right? Weight could be different. This is just an output, or in terms of this neuron, this is the input coming from the previous layer. Are you clear?
Yes, sir.
আতাউর রহমান কি আছো?
Yes, sir.
তখন রেসপন্স করো নাই। আচ্ছা, suppose this is a sigmoid function, this activation function. But if you want to apply another activation function, this is a ReLU activation function that Masugaran was asking, that is ReLU is an activation function? Yes, it is an activation function, and you can use that activation function as well. So that's all the component we discussed. It is in a কি বলে part by part করা আছে, but everything is put together in this code, I guess. আচ্ছা না, put together করা নাই, আচ্ছা যাই হোক। So that's all actually. That's all about our forward propagation. Are you clear, everyone? At first, we tried to understand the forward propagation through the lecture, the each node. Now I just showed you that whatever we discussed, we just implement those discussion using this code. So do you have any question? You do not have?
স্যার
বলো।
স্যার আমরা এখানে যে আউটপুটটা পাইলাম স্যার, এটা স্যার যে কোনো একটা লেয়ার স্যার?
না না না, একটা লেয়ার না, এটা একটা নিউরনের। সাপোজ in the first hidden layer you have 3 neurons.
ইয়েস
Whatever
স্যার।
I just show you, this is the output of one neuron only. বুঝতে পারলাম?
জি স্যার, জি স্যার।
সো আমি তোমাদের সাথে এটা শেয়ার করেছি। এখানে অনেকগুলো কোড দেখো এরকম মিসিং। তোমাদের কোডগুলো ফিল আপ করতে হবে। বুঝতে পারলা? আমি এখন যা দেখালাম অনেক কিছু হচ্ছে তোমাদের অ্যাকচুয়ালি এই করে নাই। So your lab task is you'll have to complete this next
স্যার
week.
এটা ডেডলাইন কি আজকে?
না, next week.
ঠিক আছে, তাহলে ঠিক আছে।
সো তোমাদের হচ্ছে গিয়ে এইটার জন্য করতে হবে, একটু লিখে নিতে পারো যে হচ্ছে তোমাদের in your for your homework you will apply input, number of input is 1, number of hidden layer is 2, first hidden layer একটাই নোট থাকবে, second hidden layer দুইটা নোট থাকবে, output layer only one node. So you can take this code as a note. So based on this note, you'll have to complete the rest of the note. Everything I just discussed, if it will enough. So guys, do you have any question or any confusion that I might can solve?
স্যার, নো কনফিউশন।
সব বুঝে গেছে?
সলভ করার সময় তখন স্যার হয়তো প্রবলেম ফেস করতে পারি।
আচ্ছা, বোঝার সময় কোনো প্রবলেম হচ্ছে না, তাই তো?
জি স্যার।
ওকে, তো তোমাদের অ্যাটেন্ডেন্সটা নিয়ে আমি।
স্যার ভ্যালু গুলো যেটা দিয়েছেন এগুলাই কি, যেখানে মানে আপনার স্ক্রিনে যেগুলো দেখা যাচ্ছে?
না, এটা ছিল এটা।